The COVID-19 pandemic was officially declared to have transmitted in Indonesia on March 2, 2020, with the first 2 positive cases. Now, Indonesia is up to more than 1 million total cases and 37,000 deaths. During this global pandemic, health protocols remain the most important factor in regulating and minimizing COVID-19 transmissions. In fact, the World Health Organization has described hand hygiene as the single most important measure people can take in order to prevent the transmission of COVID-19. Since the pandemic started, more portable hand washing stations have emerged in major parts of the city. In fact, by washing our hands, the risk of contracting the virus drops by 35%. Unfortunately, not every area is guaranteed access to hand washing stations, and most of them are not touch-free. With the need for infection control measures still very much a key priority, one significant way to improve hand hygiene compliance is to make the process itself easier and touch-free in order to remove the risk of cross-contamination from taps and soap dispensers and the need for manual technique. Therefore, I predict that if we apply the concept of fluid mechanics, then we can propose a solution to reduce contact among people. A comprehensive study on various articles and publications regarding past or ongoing physics studies was conducted, and it will be the basis of all the reasonings to support or oppose the prediction. The methods of the experiment include a Gedanken experiment that uses a conceptual rather than actual approach, as well as thorough observations. After conducting research, I came up with a solution that would aid in removing the risk of contamination from taps and soap dispensers, which is a foot automated faucet. But before we get into the results, let's know more about fluid mechanics and Bernoulli's equation. So, what is fluid mechanics? As the name suggests, fluid mechanics is the study of fluid behavior at rest and in motion. There are several fluid mechanics theories and concepts such as buoyancy, Archimedes' principle, hydropressure, and the Bernoulli Equation. However, it is most fitting that the main issue of cross-contamination from faucets be resolved by applying the Bernoulli Equation. Bernoulli's principle, or the Bernoulli Equation, is a seemingly counterintuitive statement about how the speed of fluid relates to the pressure of the fluid. It states that within a horizontal flow of fluid, points of higher fluid speed will have less pressure than points of slower fluid speed. We can think of the Bernoulli's equation as a statement of the conservation of energy. It says that along a horizontal flow of fluid, the sum of the pressure energy, kinetic energy, and potential energy remains constant. Essentially, the Bernoulli equation says that if an incompressible fluid flows through different sizes of pipes, the fluid velocity changes. This change creates an acceleration in the system, which creates different forces and pressures on the pipe's cross-section area. Now that we know the basics of fluid mechanics and Bernoulli's equation, we can see how it can be implemented in the foot automated faucet. Displayed on screen is the front and back view sketch I've managed to draw of the proposed solution. The foot automated faucet is composed of several important parts, including a touch-free faucet, a 20-second timer, and a foot pump. A 20-second timer is essential because evidence suggests that washing hands for about 15 to 30 seconds removes more germs from hands than washing for shorter periods. This is further recommended by the World Health Organization and the Centers for Disease Control and Prevention, or CDC. So how does the foot automated faucet work? Once a foot pushes up against the foot pump, it will easily pump water from the water storage up the different sizes of pipes directly to the faucet. It's as simple as that. From a physics perspective, the change in fluid velocity due to the different sizes of pipes creates an acceleration in the system, which creates different forces and pressures on the pipe's cross-section area. This will help create an efficient and effective water system for the foot automated faucet without having to touch the faucet itself. All in all, from a research findings on the issue of cross-contamination from faucets, My hypothesis is proven to be correct because fluid mechanics can be used to create foot automated faucets and is further validated by applying the concept of the Bernoulli Equation. Therefore, I will share the solution I proposed by publishing it on YouTube to raise awareness on the importance of hand hygiene during this pandemic and to reduce the possibility of cross-contamination from faucets. The relation between this project and the big question is that rationality is a moving force that enables a visionary leader to think logically in order to execute tasks and reach a designated goal. In this case, it is highly essential in developing an idea or innovation that would help transform our society with the magic touch of physics. Whether we realize it or not, almost all of our day-to-day activities involve physics. Physics helps shape the world to what it is now. Its influence extends to all sciences and many other fields. Therefore, we can transform the new world with the magic touch of physics by upholding various physics concepts. This project is correlated to 3 Sustainable Development Goals, which include good health and well-being, clean water and sanitation, as well as life on land.